Hi everyone, this is question number 12 from textbook section 8.1. Let's read this question carefully, because if we can interpret this question sentences correctly, that will enable us to answer the question correctly. So it says, assume that the population of heights of men has a normal distribution with a mean of 69.5 inches. That means the entire population of men's height is normal with mean mu is equal to 69.5 inches. And the next part of the question says, and random samples of 100 men result in sample mean heights with mean of 69.5 inches. So notice that this is plural. So, and they're saying that if we took thousands of random samples, each sample having 100 observations, then we could calculate thousands of sample means, and the distribution of sample means would also have a mean. The distribution of sample means would also have a mean, which we call by mu of x bars, equal to 69.5 inches. And that makes sense because we saw this result several times in our class lectures, that mean of all the sample means turns out to be the same as mean of the population. They are also giving us another piece of information, which is the standard deviation of the sample mean distribution is 0.24 inches. So sigma of x bars turns out to be 0.24 inches. So part A is asking us, if one random sample of 100 men results in a mean height of 69 inches, so they're saying randomly pick one of these sample means, one of these x bars, and that turns out to be exactly 69 inches. I'm just writing 69 to the left of 69.5 because it's smaller than the sample means mean. How many standard deviation is the sample mean from the population mean? So they're saying how many standard deviation is this 69 from the population mean 69.5 under my x bar distribution. So we have to figure out this distance instead of the standard deviations. So we can figure that out by deducting 69.5 from 65 and dividing it by the standard deviation of the distribution of x bar, 0.24. And if I bring out my calculator, then on the numerator I have 69 minus 69.5, which will give me a negative 0.5, and I'll divide that by this 0.24. so 0.24 gives me a value of negative 2.08 approximately. So I'll write down this equal to negative 2.08. and notice that this is actually z value, because definition of z was how many standard deviation away an observation is from the mean under that distribution. So I can actually view this 69's z value, equivalent z value, as negative 2.08, and we know that the z value of the mean is always 0, because mean is exactly 0 units away from the mean itself. So now if I go to my z table, I can figure out the percentile position of this z. So let me bring out my z table. Z value is negative 2.08. So I'll go to negative 2 and then go to the respective column that coordinates to 0.08 on the top column. So z value of negative 2.08 gives me a percentile position of 0.0188. 0.0188. So that's the percentile position. Percentile position of this z value. And if you want to express it in 100 based form or percentage form, all you need to do is multiply this value with 100%, or the simpler technique is to bring this decimal point to the right by 2 digits. So that will give you 1.88 percentile position, which simply means that only 1.88% of the area under the curve lies to the left of 69. So this area is 1.88% of the total amount of area covered by the distribution. And that actually also answers question number B, which asks us, what is the probability that a second sample of 100 men would have a mean less than 69? In other words, under this distribution, if you closed your eyes and randomly picked one of these thousands of x bars, what are the chances that that x bar would be less than 69? And that probability is simply shown by the area under the curve to the left of 69, which is 1.88%. So answer to part B of the question is, there is 1.88% chance. And answer to part A, of course, is simply this z value, or in other words, you could say that this 69 is about 2.08 standard deviation away from this mean of 69.5. I hope that helps you to understand this question, and I'll be back with more answers later on. For now, I'll say bye.